let's just look at a certain number like 50, okay? You're looking at 50 and you want to take a square root of this. Now, what's different is that this is not a perfect square, okay? There isn't any number that I could use to get a perfect square of 50 square units. Meaning, if I did 7 times 7, each of these sides had 7 and 7, okay? And I had 7 rows here, 7 rows here. There's no way I can make a perfect square of 50. And if I go up one more, 8 and 8, that's 64. So you see it kind of skips here 50. All right? Now a lot of your perfect squares you look for 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 225. I believe you should know up to this number as far as your perfect squares. Okay, these you should have memorized. 1, 2, 3, 4, 5, 6, so on and so forth. So since we don't have a perfect square, we have to simplify this by using factors. Now, what's a factor? Okay, let me just look at your 2 and 25. What's a factor? A factor are the numbers that I can use to multiply and get 50, which would be 1 and 50, 2 and 25, and like 5 and 10. Those are some of your factors there. Those are some of your factors. Now, if I'm looking at 50 here, okay, I broke this down to the square root of 2, square root of 25. A thing that I like about this is that I was actually able to break this down into a perfect square by 25. Now, square root of 25, 5. So to simplify this, I get 5 square root of 2. Now, this is not the only way to break down 50, because if you look here, 50 has more than one factor. I could have also used 5 and 10, and here 2 and 5. Now, one thing you want to look for when you're making basically like this radical factor tree is you look for things that repeat. You look for the same square root to repeat. Now, when the same square root repeats, square root of 5 times square root of 5, keep in mind that square root of 5 times square root of 5 gives you 25, which gives you 5. So anytime you get a repeat, it is just that number. Okay? So here I have this 5 and the 5 repeat. I have the 5 square root of 2. And notice that both of these answers are the same. Okay, so there was actually two ways to get this. Now, one thing you want to consider, okay, let's say I give you square root of 132, and you want to break this down, okay? You know that this is an even number, so you can always start with 2, no matter what, no problem. You can always start with 2. But I would always consider maybe using, if 2 works, maybe on my calculator, see if 4, 6, or 8 works. And if I get a number like 150, maybe I want to try 5 or 10. And if 10 works, maybe I want to try 20. Okay? Because I'm looking for the biggest factor, or I'm looking for some of the bigger numbers I can use, because here I have 2 and, in this case actually it'd be 2 and 66, so 2 would be the biggest number. But you may see in some other cases where, like, let's say you had a 1 and 172, which you could do 2 and 43? No, 2 and...
46.
No, you would do 2 and 86? So you could break this again down to 2 and 43. So what you may realize is that, oh, actually I could have just used 4 and 43. There was a bigger number to use. You don't have to always start with 2 when it's even. But know that when it is even, you can always start with,
It's easier way.
2. The easiest way is to use 2. The quicker way is to find a bigger number when you're factoring down, when you're simplifying this. Now, here's something that you should keep in mind too when this happens. The 3 and the 11, you see, I'm sorry, you have a 6, 6 and 11, and then a 3 and the 2. So I've broken down the 66, 6 times 11, and the 6, 3, and 2. But notice, I have a repeat here, and then look at this here, it actually gives me 2 prime numbers, right? I can't simplify these numbers anymore, right? Remember we talked about the numbers repeating? When a number repeats, just a pair, it just becomes that number. But then you're left with square root of 3 over square root of 11. You can't leave it with the 2 radicals, okay? So what you would actually do is, like we said before, you would recombine these. You would multiply together and get back to a 33. Yeah, you would multiply and get back to a 33. Now another one you want to look at is one where they present variables when simplifying. Now, what I like to do is let's look at the number first. Let's look at the 12. Now here's that idea. I could do 2 and 6, but I know there's a bigger number that goes into 12, and I know one of those numbers is actually a perfect square. And let's put a square around it. That's a perfect square. So actually I'd rather use the 4 here. And the reason for that is it's quicker to simplify. I can go right to the 2.
And
So
the 3
square root of 4, 2, and the 3 here. Now let's look at the letters. What you have to consider is that there's a square root, basically a second root. You have a 2 out there. So what's happening is you're having x with 7 divided by 2, and you have a y with 6 divided by 2, okay? So basically you're taking this number and dividing it by this outside number here in a certain way, right? Now, 2 goes into 7 3 times with 1 left over. You have that remainder of 1 here. That's a remainder. That's something that's left over. So what you do is you put 3 of the x's on the outside, and since you have the remainder of 1, that's going to stay on the inside there. And then when you look at the y, which is 6 over 2, this actually divides evenly to a 3. So you just have the y to the 3 out here. There isn't any remainder, so the y is finished. You're not putting any remainder in there, right? And the reason for that is, think about it. If I'm taking y to the 6, and I'm taking the square root of that, and I'm basically trying to figure out, is there something multiplied by itself that give me y to the 6? Yeah, y to the third times y to the third. When you multiply variables with exponents, you add them, is in fact y to the 6th. Is in fact y to the 6th. So when you're working with the numbers and variables, look at this separately, then evaluate these, and you're just going to end up dividing. And again, when you look at numbers, like a 200, yes, I could do 2. Ooh, this is actually, I got lucky with this one because this gives me a perfect square. So I'm done here, 10 and 2. So sometimes it does work, but then there are other times, like maybe you get a 168, where, okay, instead of just doing 2 and 44, let me try doing 4, which would be, actually 4 would be 42 there, right? So you could use bigger numbers instead of using a 2. And there's always more than one way. And the key for that is, well, with what we're doing now, is when you're working with this Pythagorean theorem, which we're going to talk about, and you have to basically a squared plus b squared equals c squared. At the end of this problem, you're going to have to take a square root of a number. And a lot of times that result is not going to be a perfect square, so you're going to have to come up with